All right, quadratic functions. Okay, our standard form is ax squared plus bx plus c. Right, this is the most common way that we see a quadratic presented to us. The parent function of that is just x squared. Right, so it's a parabola. We know what a parabola looks like. Okay, this is a positive parabola, y equals x squared. And then if I throw a negative sign out front, when we talked about transformations, we know that just reflects across the x-axis. So we end up with an upside down parabola. Right? So if a, and a is our leading coefficient, right, the number out in front of the x squared. So if a is greater than 0, the graph will open up. Okay, and if a is less than 0, meaning it's negative, the graph will open down. Okay. I don't really know what they wanted to put. I'm assuming they wanted positive and negative value, but that doesn't make sense if it's shifted at all. Right? If this graph is shifted down, some of the values are going to be negative, but it'll still open up. So I don't really think that positive and negative makes sense there. All right, so I'm just not going to put anything in there. So right off the bat, okay, let's review a little bit of what we talked about in the last chapter by using those transformations. So if we're given any negative x minus plus 1, okay, we want to equals x squared. What's going to happen with x squared? What's going to happen first? Right 5, right? That'll be the first happen, because that's inside. It tells me to do that first, right? And finally, the plus 1 of 1, right? So we should end up with something that looks like this. Right, so what is the vertex of this parabola? Yeah, so the whole point would be 5, 1, right? The vertex is the point, right, where it's either, if the parabola is facing down, it's the greatest point. If the parabola is facing up, it's the smallest point. So in this case, is the vertex a maximum or a minimum value? It's a maximum, right? The vertex is at the very top of the parabola. Right? So let's take a look at a quadratic given in standard form then. Okay, and we want to graph this one as well. So we can't just use our transformations on something like this, right? Because it's not presented to us in that form. So one way of graphing a quadratic like this is to factor it, find the zeros, and then find the vertex from there. So first, how would we factor this? Yeah, x factor. Right, so we're looking for two numbers that multiply to negative 5 that add to positive 4. So what do we have? Both positive? 5 and negative 1. So that means this would factor into x plus 5, x minus 1. So what are my zeros? Negative 5 and positive 1, right? So we're setting both of these equal to 0. So we get x equals negative 5 and x equals positive 1. So I know those 2 points are going to be on my graph. So 1, 2, 3, 4, 5, and 1. Now from that, we can find the vertex. Does anybody remember, if I know the zeros, how to find it at first, just the x-coordinate of the vertex? How would I find the x-coordinate of the vertex if I know the zeros? Yeah. The x-coordinate of the vertex is going to be exactly halfway in between the two zeros. Okay? So if my zeros are -5 and +1. The midpoint, okay? We just take the average of those two numbers, right? So the average of -5 and +1 would be -2. Right? -5 plus 1 is -4 divided by 2 is -2. So I know that the x-coordinate of my vertex is going to be -2. How would I find the y-coordinate then? What would be the easiest way to find the y-coordinate if I know the x-coordinate?
Oh, you just
Plug it in, all right? Just plug it into my equation. So I'm going to evaluate f of -2. So what do we get? 4 minus 8 minus 5. So -9.
use.
So the vertex is going to be at -2, -9. So my parabola will look something like this. Okay, so we found the vertex to be -2, -9. Now, this time, is that a minimum or a maximum? Minimum, right? Our parabola is facing up. So that's a minimum point. Okay? So if you want to make a note, okay, it might be a good idea to jot down the vertex, well, x-coordinate of the vertex is halfway between the zeros, okay, or the x-intercepts. Questions so far? All right, so if we are given an equation in the form of our first example there, okay, one thing that we can do is use our knowledge of transformations to figure out what the graph looks like. But this form is also known as vertex form. Okay? If I have something in this form, okay, so we can do an example as we go. And if I've got 2 times x plus 3 squared minus 4, something like that, okay, the vertex is given to me in this form. The vertex of this parabola is the point HK. So in our example here, 2 times x plus 3 squared minus 4, the vertex, okay, since I have a negative sign here, this is the x-coordinate of the vertex, but I always take the opposite sign. So for our example, the vertex would be -3, -4. Okay. So again, just like on the front, okay, if our leading coefficient is positive, the graph will open up. The leading coefficient is negative, it'll open down. Okay? So vertex form is very helpful when we want to graph. Okay? Just by looking at the equation, I can see what vertex is. Okay? I don't have to do any work. Like we had to factor on the last one and do a little bit of extra work to figure out how to graph the function. Okay? If I have it in vertex form already, I know the vertex right off the bat. Okay? And I can start graphing. So, if I'm looking at these 3 examples down here, what is the vertex first, and then second, does it open up or down? So in this first example, what is my vertex? -1, -5. Does it open up or down? leading coefficient is positive, so it opens up. Okay. You guys take a second and try B and C. We get 5, 0 and down for B, and then 0, 2 and down for C. We okay with recognizing a vertex from vertex form?
I'm confused. How do you know if it goes up or down?
So we're just looking at the leading coefficient. So right here, this is a positive value. So it opens up. Negative value opens down. Negative value opens down.
Gotcha.
Any other questions? All right, so in this next example, we want to both sketch and write an equation for a parabola given the vertex and some random points. Okay, so in my function, okay, or I guess we can start with the graph. I know the vertex is at -3, +4, and then some other point on the graph is -4, +7. Okay? From that information, I'm going to write the equation. Okay, well, if I'm thinking about vertex form, right, we know that it's f of x equals a times x minus h squared plus k. Right? Well, I know a couple of those pieces of information. Right? I know my h and my k, so I can plug those in. And I don't know an a value, though. So I'm going to say x minus -3 squared plus 4. Okay? And we can simplify this. The x minus -3 would just be x plus 3. Okay? But now, how do I figure out what a is? Given another point on the graph, how would we figure out what our a value is? Any ideas? So I guess it might be a little more obvious if instead of f of x we write y. Does that actually give you a hint? So if I want to solve for a, and I have another coordinate point, yeah, I'm going to plug this in for x, plug this in for y, solve for a. So my y will be 7, my x will be -4. Now I can just solve for a. So a times -1 squared plus 4. -1 squared is just 1, right? So this just becomes 1 times a. So a plus 4, subtract the 4 over, and we get that a is equal to 3. So my final equation equals 3 times x plus 3 squared plus 4. Okay, and then to sketch the graph, okay, well, we know this is the vertex, and then a parabola always symmetric. Right? So if we have this point, I would also have this point. Okay, and then sketch what our graph will look like. Are we okay with that process? Okay, so given a vertex and some random points, okay, we can use this process to find that equation. The next thing that we want to take a look at is converting an equation that's in standard form to vertex form. To do that, we are going to complete the square. You guys remember how to complete the square? No. So, in an equation like this, okay, I've got x squared plus 6x minus 10. What I want to do is split this up into two different parts. Okay, I'm going to take this x squared plus 6x, and then I'm going to add something to that, okay, to complete the square. And I'm going to add something to that to complete the square. Now, what we can think about is there's actually two ways we can do this. I think the way that is less confusing is probably to bring this 10 to the other side, okay? So we're just going to say this is 10 equals x squared plus 6x plus some blank, right? Now, whatever I do to one side of the equation, I'm going to have to do to the other, right? So whatever number I add over here, I'm also going to have to add over here. This number that I add to both sides, I'm going to take my b term. Okay, so the b term is whatever number is in front of the x. Divide that by 2 and square it. So in this case, I'm going to take 6 divided by 2. We get 3. And then 3 squared is 9. I'm going to add 9 to both sides here. The reason that we do that, okay, this now is a perfect square trinomial. Okay, I can factor this into something squared. That form, okay, will always be x plus whatever that b over 2 was. Okay, so in this case, this will factor into x plus 3 squared. On the other side of the equation then, we have 9 plus 10 equals 19. So now, to finish this out, to put this actually into vertex form, move the 19 back over. And we can say this is x plus 3 squared minus 19. So, first, move your constant to the other side of the equation. Then take half of your b term, square that, and add that to both sides of the equation. Then take what you've created here, factor this into a binomial square, then move your constant back over. Right? You okay with that process? So now what is the vertex? We can just look at this and see the vertex now. -3, -19. Okay? You guys want to do another one together, or do you think you can try one? Another one together? All right. So on this one, the first thing I want to do is move my 7 over. So subtracting that this time since it was addition. So now I have to figure out what number to add to both sides of the equation. To do that, I take half of my b term, so half of negative 4 is negative 2, and square it. So negative 2 squared is positive 4. So I'm going to add 4 to both sides of the equation. Now, what we created over here is a perfect square trinomial. So this will factor into x, whatever half of b was. So we said half of b was negative 2. So this will be x minus 2 squared. And if you ever forget that trick, this number should be half of b, just x factor this, right? And that's all we're doing. We're looking for two numbers that multiply to positive 4 that add to negative 4. Well, negative 2 and negative 2. Right? So this would factor into x minus 2 times x minus 2. Over here then we have negative 3. So adding the 3 back over, this becomes f of x equals x minus 2 squared plus 3. My vertex then is at the points 2, 3. Pretty fancy. Questions? Alright, why don't you guys try C?
Why don't you try? Mr. Patrick, you killed someone before? Nope. Alright, we need to. Are you sure you're not lying? I'm sure. All right. Those numbers are correct.
They are, but it still works. Did we get something like this? Okay, so we can still go through this process even with ugly numbers, right? Since my b value was odd, taking half of that, I get a decimal. Okay, and then squaring 2.5, get 6.25. So we should end up with something like x plus 2.5 squared plus 2.75. So my vertex is negative 2.5, 2.75. So this last one then is a little bit different. Right? My leading coefficient isn't 1. Right? On A, B, and C, we just had a 1 out in front of the x. Well, it's a similar process. Okay, the first thing I want to do is move my 8 over. So I'll have negative 8 equals 5x squared minus 20x. But to do this, I do have to have a leading coefficient of 1. That means I have to factor a 5 out from this side. So I need to change this to 5 times x squared minus 4x. I'll put the number I need to add there on the inside. So I want to complete the square just like we did. Okay, and this one actually ends up being the same as this one up here. Okay, my b is negative 4, so half of that is negative 2. Negative 2 squared is positive 4. So I'm going to add 4 to this side, but I'm not going to add 4 to this side. What number should I add to this side? 20. Oh, 5 times 4. Okay, so that's a small thing that we have to be careful of. Okay, whenever we have a leading coefficient that isn't 1. Okay, I'm adding 4 here, but what I'm really doing is adding 20. Right? I'm adding 5 times 4. So we need to make sure that we add the appropriate number to the other side. So now, I can factor this. So I guess this would be 12. And I'll end up with 5 times x minus 2 squared. Subtract the 12 back over. We get 5 times x minus 2 squared minus 12. So what's my vertex? Negative 12. Questions on completing the square? All right, then let's flip over here. Okay, and take a look at the graph that is in vertex form. Okay, so first, to graph this, it tells me to find the vertex and then find 2 other points. So what is my vertex here? Negative 1, 6. Negative 1, 6. So what would be an easy way to find 2 other points on this graph? Any ideas? I think the easiest way would probably be to just choose 2 other x values and plug them in, right? Usually, we would want to choose 1 x value on either side of my parabola, okay? So, I could choose x equals 0, right? That would be an easy point to find the y-coordinate of. So, f of 0 would be negative 3 times 0 plus 1 squared plus 6. So we get negative 3 times 1 plus 6. So negative 3 plus 6 would be 3. So the point 0, 3 is on my graph. Without doing any other arithmetic, what would be another point on the graph then? Negative 2, 3. And because a parabola is symmetric. Right? So if 0, 3 is on the graph, my vertex is right here. This point will also be on the graph. So we found 2 other points. Right? We can sketch our graph now. Get something like this. You okay with that one? I think we're going to skip example 7 here. It's the same idea. And we'll jump down to the bottom. So if we have an equation in standard form, okay, we can either factor, like we did in the example on the front. We can complete the square to find the vertex, which we did. Or, okay, we've got a third option. we can either figure out the x-coordinate of the vertex without converting to vertex form. Okay? This little equation here, x equals the opposite of b over 2a, will tell me the x-coordinate of the vertex. So if I'm given an equation in standard form like this, x squared minus 2x plus 4, I can say, well, the x-coordinate of the vertex is going to be the opposite of b. So b is negative 2, right? So the opposite of negative 2 over 2 times a. In this case, my a value is 1. So we end up with 2 over 2. So the x-coordinate of my vertex is 1. Well, to find the entire coordinate then, I can just plug 1 into my function. So 1 squared minus 2 times 1 plus 4. So 1, negative 1, 3. So my vertex is the point 1, 3. Okay, then it says, find at least 2 other points. Well, again, plugging in 0 seems like it would be a good option in this case. So I can evaluate f of 0. That would just be 0 squared minus 2 times 0 plus 4. So 0 minus 0 plus 4 gets me that the point 0, 4 is on the graph. Well, if 0, 4 is on the graph, using symmetry, that would also mean that 2, 4 is on the graph. And I can sketch my parabola. Okay, so we've got a few options. Okay, we can try to factor to find zeros. We can complete the square to find the vertex, or we could use this. Okay, if we are given our parabola in standard form, right? The opposite of b over 2a tells me where the x-coordinate of the vertex is. Okay. Right, so let's try one. Okay. We've got negative x squared minus 4x minus 7. Okay, find me the vertex and find me 2 other points and sketch the graph. we get something like this. Vertex at -2, -3. Facing down. We can choose some points like that. Any questions? Alright, one more. Okay, let's take a look at example 10 here. Okay, so it's a given minimum. How would I know that just by looking at the equation? Right, okay. Our A value is positive, meaning the parabola is facing up, so it's going to be a minimum. Well, how do I find that value? That's the vertex, right? So, just like we've been doing, okay, we can say, well, the x-coordinate will be -b over 2a, so that'll be -4 over 2 times 1. So 4 divided by 2 is 2. Then I just plug that in. So f of 2 will be 2 squared minus 4 times 2 plus 3. So 4 minus 8 is -4 plus 3 is -1. So my vertex, or the minimum, is at 2, -1. Well, from that, how would I find the range then? If I know the vertex is at 2, -1, and the parabola is facing up, what's the range of this function? -1 to infinity, right? We've got something that looks like this. Okay, I don't need to know how fat or skinny the graph is. All I need to know is the smallest y value we reach is -1. So the range will be, so -1 should have a bracket, right, because we are including that, up to infinity.